Hello, everybody. There we go. Thank you. I don't have any flashy audio-visual presentation to give you, I'm afraid. I won't also crash your laptop either, so it's a bit of a trade-off. So I'm here to talk about cloud native. I want to say thank you for coming along to this session, and also thank you to the organizers for inviting me. I think it's the third Craft Conf I've done. It's still the nicest venue. It's not necessarily convenient, but it's the nicest venue because we're surrounded by proper engineering. It always puts us in a place a little bit. We talk about what we do as engineering when I have this next to me, which actually has to work and not kill people. Well, not anymore anyway. It does, though, you know, I am now getting a bit of a nightmare that it might start slowly rolling towards me during this talk. I'm here to talk a bit about cloud native, mostly because I seem to be existing in my elder times. Now I'm past 40, I seem to be existing permanently in a state of bewilderment about what's going on in the world. What are these kids doing? Why won't they get off my lawn? Stop coming up with new words. And this is an ongoing, almost now 2-year-long midlife crisis that I'm having in a public forum, so you can share along with me. I do have my own consultancy now, if you want to know more about what we do, but it's training consultancy, workshops you can find out online. I also wrote a book which is available on the O'Reilly stall. I don't want you to buy it just for me. I want you to think about Helen, who brings all the books here, and then if you don't buy it, she's got to take them back again. And it would be great if you could help her take that off her hands. So we are here to talk, though, about confusion, partly my confusion, but partly also the confusion that I see out there when talking about the topic of cloud native, because it seems to mean so many different things to so many different people. And I'm seeing this actually quite viscerally at the moment. I'm helping, I sort of help chair a conference on the cloud native conference in London, actually, and we're seeing the submissions coming in, and it gives me a good indication of how practitioners view the topic of cloud native, and I still think we're missing a trick. We're going to go through this in a bit more detail, but I want you to just remember two things about the creation of cloud native applications and the whole space around cloud native. There's just two things I want you to remember, the third being by my book, but the first two things I want you to remember are it's all about abstractions. This is it. It's just all about abstractions. That's the first thing. It's all abstractions all the way down, right? The second thing, it's definitely not all about Kubernetes. In many ways, Kubernetes is the single least interesting thing in cloud native. It's a means to an end. So if you could stop bombarding my cloud native conference with 99 different presentations about how you run Kubernetes, that would be great. Let's actually take a look at, do a very quick potted history of cloud and the backdrop we have of building applications on the cloud and using cloud platforms. We can't really cover that unless we talk about AWS, Amazon Web Services. And obviously, this is sort of the great prior art when it comes to thinking about using somebody else's resources to build our custom applications. And we think about it, we couldn't imagine the world without cloud platforms like AWS, Google Cloud, or obviously Microsoft Azure. The reality is this is still a very, very new space. The very first public offering around AWS was SQS, a simple queue service, which was of limited use by itself with nothing else around it. That was only in 2006. So in the grand scheme of things, we're talking about a revolution that's happened in sort of a 12-year period. But you could go back further to really understand some of the prior art and the way the direction the world was heading in. When I was trying to get people to adopt AWS, one of the best tools in my arsenal would be the fact that I could talk about other cloud-oriented software. I'd get that pushback, well, I can't run my stuff on other people's computers. And I'd be able to say, you're using Salesforce, aren't you? Because you are using Salesforce. Whether you want to or not, it's there somewhere in your organization. Salesforce is a company that built a very profitable company on a cloud. It was one of the first big SaaS companies, and you can't underestimate how important that was. This was 1999 when Salesforce first started. So you're there talking to a CIO who won't let you run custom software on somebody else's cloud, but they'll quite happily put all of their data into somebody else's hands through tools like Salesforce. And by showing the value that comes from not having to worry about all of these things, it opened up the doors for us thinking more further about how we could actually use the cloud to build our own custom applications. I think a watershed moment really came for me personally, at least, was when Heroku first was launched. Heroku had been around from 2007, still, in my opinion, the gold standard for a cloud-oriented platform as a service. and has a user interface, the command line being a user interface so good that pretty much every other cloud vendor subsequently has stolen the user interface, and I think the world has been a better place as a result of that. Because ultimately, they got a lot of stuff right, albeit in 2007. Again, we're not talking about a long period of time here. But we're all here to know what is cloud native, that's the title of the talk, and really what is a cloud native application. So let's start looking through some definitions of what cloud native applications and some sort of bits of information out there about what a cloud native app might be. Let's start actually with some prior art from Heroku, who famously put out a thing called the 12 factors. You can view the 12 factors in sort of a generic way, separate, but really this was a playbook of how to build applications well so they worked on Heroku. People building the Heroku application were realizing that people were taking existing systems, trying to move them onto Heroku, and they don't quite fit. There are limitations or abstractions or constraints that come with any cloud platform, and these things weren't well understood. And the 12 factors went some way to explaining how we should think about building an application so that it at least won't be fighting the cloud actively. There's lots of useful information in here. Although it was maybe influenced heavily by how Heroku works, there's still great information here. It's talking about things like how we consider backing services, thinking about them as just being, external dependencies, which plays a lot into how we think about microservice architectures today, and also changing the way we think about scaling by process. This is the reason why people kind of like container-based systems. There are other definitions that sort of allude to what cloud native might be. There is a body called the Open Data Alliance who have put out the Open Data Alliance maturity model for cloud native applications. This is one of the first concrete definitions I found for a cloud native application. Already from the slide, you can see that we're in for a treat. So let's dive into what the maturity model is. I always love a good maturity model because I actually think they're terrible things by and large. So there's always lots of fun to be had by poking holes in them. So let's take a look at level 3 adaptive cloud native applications. And here was the main point for them, that the application can dynamically migrate across infrastructure providers without interruption of a service. So I'll call bullshit. Can I say that? I just call bullshit on that statement. Who builds applications that dynamically migrate across provider without anybody ever noticing? It's a myth. No one needs it. You might, as an organization, have a multi-cloud strategy. Absolutely. That's a very different thing from saying my application will dynamically move from one provider to the other. This actually harks back to a day when we thought we'll be dealing with like arbitrage, abstractions, and going to the lowest cost provider. And that world hasn't happened because primarily cloud computing is not utility in that sense of the word. And let's also say that based on this definition, the kinds of applications created by companies like Google and Netflix are not cloud native according to the Open Data Alliance, because they don't, Netflix run their systems across multiple regions in AWS, but they're not deciding to, I know, it's a bit cheaper, let's go run it on Azure while we're at it, because they understand the cost of making that work drastically outweighs any benefit you may get. Okay, so that's not a great definition. The Heroku stuff, the 12 factors, is getting us close. The Open Data Alliance definitely isn't helping us right now. So let's take another stab. Okay, so who else might have a great definition of what a cloud-native application might be? Well, let's go talk to the Cloud Native Computing Foundation, which is sort of the body that oversees a variety of different projects in this space. We'll come back to some of the work they do a bit later on, but they have a definition. It's quite clear, actually. It comes out of the charter. There's 3 key points they talk about a cloud-native application having, and they say it's container-packaged, dynamically managed, and micro-service-oriented. So these 3 points, container-packaged, dynamically managed, micro-service-oriented. So let's talk about container-packaged first. Why should anyone care about containers? I, as an old Unix geek, think containers are amazing. I actually think most of you shouldn't care anymore, but they come up so much that we should at least talk about why they might be useful. And I think useful here is an implementation detail. Containers give us some very useful properties that can help us work in these types of environments. The first thing is they give us quite a cost-effective mechanism for isolated execution of process. That's useful because in a cloud environment, we want to avoid the noisy neighbor problem. I don't want somebody else's process running hot to affect my process. Containers give us very cost-effective isolation, and therefore you can coexist different processes from different customers or different users in an internal system with a better with sort of a more cost-effective isolation than virtual machines. Great. They also give us a universal deployment, which is useful, again, in a cloud platform that might want to support a variety of different technologies. I shouldn't care if it's a Python app, a PHP app, or a Ruby application. It's just a container. That gives you uniform deployment processes and universal management tools. Useful. They're also portable. The container formats allow us to move theoretically from provider to provider. I still think this is actually quite low level, and so I don't think your application is only cloud native if it uses containers. Let's think about building a system which is built entirely out of functions and backing services like Dynamo or Cosmos or something like that. So I might be on AWS or Azure. I might be using Cloud Functions or Lambda. That's functions. I'm not working with containers. That's not a detail. Containers become, effectively in that environment, an implementation detail. And increasingly, I think as we see higher order abstracted cloud computing primitives, containers are going to become less and less important. Kubernetes may have won the war in terms of container orchestration. I think most of you won't care about containers in a couple of years, and they'll be gone. So I think the idea that we should fixate on that is I think it's a bit wrong in a way. So container packaged, I'm not convinced. Dynamically managed is a big part of the cloud native. Here what we're doing is we're offloading a large amount of the management of our application to the underlying cloud platform. So here we're typically talking about the application doing things like right-sizing. So maintaining desired state is sort of like table stakes in this world. I want 5 machines. There should always be 5 machines. You make sure that happens for me. That's at the base level. Getting more advanced, you'll have things that will scale up to accommodate demand and scale down, thereby reducing your costs, giving you fault tolerance and sort of failure zones, things like availability zones, to think a bit more at a higher order around your resiliency. So this sort of idea of dynamic management and pushing that to the platform, I'm totally on board with. These are things that are very hard for us to do when building our own systems. And next, of course, we have the micro-or service-oriented point. I have 2 problems with this. I think you can guess about the first one is it's micro-service. That's not how it's spelt. I was very firm on this. I wrote a whole bloody book without any hyphens in it around the word microservices. So I've had a conversation with the CNCF, and they don't seem to want to change it. But I think we can all agree how they spell it is stupid, and you should tell them all of that to their faces. No hyphen in microservices. But I have another issue, which again, for me, fixating on microservices, I think might be missing the point a little bit. And to some degree, a microservice deployment mechanism is a bit like a container-based deployment mechanism. It's sort of an implementation detail. Is it that important? If your application isn't made up of microservices, does that mean your application isn't cloud native? Lots of people, they seem to think it is, think it's part of the puzzle. Pivotal, when they talk about cloud native, almost talk about the 4 pillars of cloud native. DevOps, continuous delivery, microservices, containers. And for me, again, these might be mechanisms by which I could embrace the cloud and create a cloud native application, but I don't think these are hard and fast requirements. They can be useful prior art, they can help us. We may want to use these tools and technologies, but again, I think it's like fixating. You've got to do DevOps to do cloud native. Well, you can't do DevOps. It's more of it's a culture thing. I mean, let's not talk about, if you are a DevOps, I apologize. Have we got any DevOps in the room? We've got some DevOps in the room, haven't we? But, it's a thing, it's a culture, it's a movement. It's not like, anyway, let's move on. So I'm not convinced about this either. Let's come back to micro-service-oriented. Why might that be useful in a cloud-native environment? How might that achieve the end goals that we're looking for? And probably the criteria I pull out here are things like independent scaling. To get cost-effective scale up and scale down on the cloud platform, it can be useful to be able to right-size different components. If you can break things apart into separate services, you get to right-size the components, makes it more cost-effective. I can totally buy that if that's the kind of operational efficiencies that you're looking for. Right tool, right job. This can also be useful in a cloud environment. I'm not talking necessarily about polyglot and picking different languages. I'm just saying, we think about the cloud computing primitives that we have available to us Different primitives might fit some parts of our functionality better than others. We can take a look at our service stack and say, well, actually, this functionality would fit really well as functions that I could run on a fast platform. Well, this stuff here, I can just run on one of the MapReduce clusters that AWS is going to manage for me. So I kind of buy that. The killer for me, though, really comes back down to this one, which is the key thing I talk about when talking about any microservice architecture. The drive around independent deployability, the ability to make a change and deploy that independent of anything else. That helped you maintain continuity of service and the rest. OK, so I've cast aspersions about how useful containers are, and I think they're pretty unimportant. I said that microservices probably aren't important either, but you should definitely buy my book. But I haven't really answered the question about what the hell a cloud-native application is. We're getting closer. Bear with me. Don't worry. We've got enough time to cover all this off. So let's go back to sort of Sam's internal journey of a cloud application. And this is sort of not a maturity model. It's more of just a style of using the cloud. And we should start with the lift and shift. Now, back in 2009, when I was first working with AWS, this was something we fought against. Because we said, look, if you just pick up your existing application and drop it on this dynamic cloud platform, you're not actually going to get the value, and it might be much more expensive. What I came to realize later on is that even if the application didn't necessarily fit what the cloud wanted to do, there was still a huge amount of value sometimes for organizations doing that. Sometimes something as simple as offloading a bunch of CapEx off your budget list and sticking this in the cloud so you could shut down data centers was immensely valuable. I've also come to realize that even if you've done a lift and shift, further migrations to make these things more cloud ready do become easier. Typically, you'll see this being an expensive operation. Your operational expenditure will increase. You will have to get new skills, even if you don't do anything with your application. And in general, I don't like doing it, but it still can be immensely valuable. So this lift and shift is where you pick something up and you drop it and you say, it'll be fine. The worst example of that I saw was one of my clients who had taken all of their existing system that was running on VMware. They'd sort of created custom VMware images of every single node in their application and just copied those VMware images into AWS. And it was an absolute horror show. So every single thing needed to be configured by logging in with virtual desktop into these Windows instances and configuring things by hand. And it was much, much more expensive for them to maintain that application in that environment because a lot of the coping mechanisms they have weren't there. But guess what? That client got to turn off a data center. That's valuable. So lift and shift, you're on the cloud, but you're fighting it. When we start getting into things that are cloud ready, you're sort of thinking of changing your applications so that it's now working a little bit better with the cloud, or at least not actively fighting against it. We're thinking a bit differently about our primitives. We're probably now building things from, the equivalence of EC2 instances, and we're connecting, EBS volumes, and we're thinking a bit more in terms of the building blocks of the cloud and mapping that to how our application works. So we're sort of working with, but we're not actively working against the cloud. Cloud native is a bit different. Cloud native is we're embracing the cloud and only the cloud. We're saying, no, seriously though, yeah, we've kind of got it to work, but what if we went all in? This is a going all in moment, right? So when I think about 12-factor apps, that for me is when you're creating an application that is working with, not against the cloud, but a lot of those things would apply anywhere. When we start thinking about cloud-native applications, you have to have a cloud platform underneath that provides you services. This is where things like the serverless offerings, I think a lot of people fixate on FAS, under that banner. I actually think the back-end databases are much, much a bigger deal, much more of a bigger deal than that. So my definition of a cloud-native application, it's an application that is built to take a full advantage of an underlying cloud platform. You can't divorce these sort of amorphous ideas of, oh, it's this. No, you're taking full advantage of the platform that you are based on. And so that probably means that your design or you're evolving your application with a specific cloud platform in mind. Okay? And that might also mean that this application is not going to work without a cloud platform. In fact, most of the time it won't. So there's a level of commitment here. There's a level of buy-in that comes from picking a platform that you are designing for and buying into the constraints of that platform. So these applications will typically be built to scale and built to dynamically scale, and you're accepting that as part of that process. You're looking for fault tolerance coming from the underlying services. You might decide the best way to achieve the fault tolerances and scaling that you need is to break things up into services, but to me, I still think that stuff is an orthogonal concern. You're pushing the work to the platform. That's what you're doing. You're embracing the platform, you're pushing the work into the platform, and this is really, really important. And we're typically looking at a high degree of automation and buying into a high degree of automation. So what do we mean when we talk about platforms? Well, we can be talking about AWS, we could be talking about Azure, we could be talking about Google Cloud, we might even be talking about your own internal platforms that you've got built and run yourself. Oh, look, I've got a Kubernetes cluster. Yeah, good for you. But really what we're talking about here, whenever we talk about platforms, is we're actually talking about abstractions. Platforms are higher order abstractions that hopefully allow us to get more stuff done. And this is the history of computing writ large. You know, when we think just from the cloud revolution, we've had multiple different levels of abstractions we worked with. When AWS first came out, we talked about infrastructure as a service, dealing with lower level primitives, storage, compute, networking. And these effectively had their analogs in the physical hardware that we ran in our data centers, and we could do a one-to-one mapping and wire these things together. You could argue we've got higher order abstractions now with things like container orchestration as a service, the ability to sort of have some sort of scheduling layer that will let us dispatch and run our container workloads in different places. A higher order abstraction. I'm not dealing with as much the detail as I once was. On top of that, I think is still where we're moving to and where we're going, the idea of a true platform as a service. The issue is, all too often, the platform as a service approach in the past was sort of seen as this all-encompassing framework that you had to buy into. And buying into that framework is difficult. I think the reality is what we're now seeing are building blocks at that level of abstraction that allow us to get more things done. Serverless fits under that umbrella. It's a higher order abstraction that gets us closer to our application code, whereas you've got things like Kubernetes bubbling around in the middle. I think the future is only going up stack. I love this Brian Marek told this to me, you know, developers, that's what we do. We do this all the time, right? We turn caffeine into abstractions. That's our job. We're used to doing this. This is not new. This is not scary. None of us work with machine code anymore because after a while we thought, let's stop doing machine code. Let's do assembly code instead. And then we thought, well, assembly code, that's kind of hard work. Let's actually start having proper application code and application programming languages. This is the history of our industry, is finding, hopefully, better abstractions. Joel Spolsky talked about how dangerous abstractions can be, especially when they're either leaky or inefficient. That's the concern. When you buy into an abstraction, you're buying into somebody else's abstraction often. That might stop you from achieving some certain things. This can be dangerous. This is partly, I think, why people start railing about lock-in. I am stuck in this place. This place is terrible. I can't get out. It's also weird, like people always assume that the walled garden is a bad thing. Some walled gardens are really nice, right? I'm an Apple fanboy. I accept I'm locked into an Apple ecosystem. It's a very nice place to be. Some places aren't. There's sort of almost different views you can take on this idea of lock-in, though, and that's actually you might be safer off with other people. I kind of like this tweet recently from one of the security people at Facebook. I don't necessarily like the language, because I think when you start talking about townships, you tend to forget the fact that the thing about a township is that a lot of people weren't allowed in the townships, and that was kind of the point. But the idea here is that from a security point of view instead, with the attackers becoming more sophisticated and our software becoming more complicated, you're probably better off having your software running in places where it can be better looked after. You know, sometimes the place where you're stuck is really nice. It's a pleasant place to be, right? A walled garden, when you've got infinite honey and if you're a bear, that's kind of a cool place. Let's come back to the Cloud Native Computing Foundation and look again at this idea of primitives, these higher order primitives. Actually, let's go further back. So Werner Vogels, who's the CTO at Amazon, did a write-up sort of looking back at 10 years' worth of his experiences behind Amazon Web Services. And one of the key things he pulled out was this, is that they lucked into a model of thinking about AWS, not in terms of an all-encompassing framework, but as a series of primitives that allowed you to decide how you want to use AWS. So you could think, oh, I kind of want this and this and this, and the other places I can make my own choices. This idea of primitives is useful because it allows us to engage with the platform in different ways. A lot of platform as a services, I think, failed in the past because it was an all-in, you like it, you lump it experience. This is a different view on it. Now, obviously, initially, those primitives that AWS offered us were quite low level. They were the classic EC2 instance, Amazon S3, and then you started getting higher order things like the RDS, where you've abstracted over a machine running a database for you, giving you some higher order controls. And they've continued to create primitives that give us higher order abstractions. When you look at the projects that the Cloud Native Computing Foundation look after, that's their prime job, is actually to curate a set of projects that help us build cloud native applications. You really just see those primitives again. You see the project names, but behind them, you're seeing the primitives that make these things useful. Kubernetes being that orchestration, that scheduling primitive that we want. We've got things around tracing, how we understand how things are connected. We start looking at some of the network overlays. These, again, are just higher order primitives that we need to assemble in different ways for our different applications. This isn't an all-encompassing framework. This is the building blocks that let us do our work. The Cloud Native Computing Foundation's one of their key drivers is actually to make this stuff platform agnostic. And this is partly because of the history of where all this stuff came from, which is basically Google's sort of night terrors over the fact that we might be looking at an Amazon-only future, right? This is very overtly a strategic direction from Google, but that's OK because everyone else was scared about the same thing. So now we have a set of tools that theoretically we can run on-premise. So we could have our very own cloud on-premise platform. And indeed, for some of my clients, this might be a rational decision. You might have legitimate concerns. You might have special cases around data and how you're looking after data, where that data lives. You might be concerned about things like the Patriot Act and data safe harbor. I get that. And so you can take these building blocks and start assembling some of these things on-premise. I will caution you about two real big issues here. Firstly, it's the whole cost of operating that platform. That is a significant undertaking. Your people are going to have to learn how to use those primitives and use them well, and now to run all the infrastructure, and probably deliver a quality of service over and above what they've been able to do historically. That is not an insignificant cost, and that's a cost that you're sort of buying into paying on an ongoing basis. The real bigger issue here is that at the moment, the portable primitives that we're being offered in the space of cloud native are quite low level in the grand scheme of things. They are, they're like networking layers and scheduling layers and orchestrating layers. But when you start looking at the really key and some of the really powerful stuff that the cloud platforms offer, they are only there on the big cloud providers. You look at this, there's a big gap here. Where are the options around management of data and data planes? Where are our storage options? There are so many little startups trying, like the little engine that could, to get something off the ground in this space. And the reality is this is an immensely complicated space. Creating a cloud-native data plane, something that you could also run on-premise, like a turnkey appliance, that's mind-bogglingly complicated, and no one's yet done it well. That's the one area where you're going to struggle. You're not going to get an equivalent of a DynamoDB or a Cosmos DB. You're not even probably going to get a very good Amazon S3 running on-premise. And this is the one gap, I think, about this vision of being able to run these things on-premise and have that portable layer. That's the gap still in the CNCF portfolio, is around data and storage. And it is, to be fair, a hard problem. Let's come back to the charter, the CNCF charter, look at some more information, some more guidance here. One of the other things they call out is their mission to create a new computing paradigm, although it's based on containers. I'm being snarky. Alexis is going to kick my ass when he hears it. Anyway, it's a new computing paradigm optimized for modern distributed system environments capable of scaling to tens of thousands of self-healed multi-tenant nodes. Now, I'm just looking a shout out. Can you put your hands up if you run tens of thousands of nodes in production? Anyone? 2 people. Cool. So 2 people need this. Right? And this is the issue. Sometimes we sort of fixate on, oh, it's got to be massive, got to be web scale, it's got to be web scale. This is not the important stuff for us, right? Now, having a portable deployment platform where I could run on Amazon, I could switch over and use a different provider at Google, I totally buy into that. Most of us are not in the tens of thousands of nodes issue. The fact these platforms can scale that well is great. Guess what? Kubernetes is still struggling with that, right? I think the biggest production deployment I know is now up to 5,000 nodes, which is something that Mesos could do like about 4 years ago. So, take that stuff with a pinch of salt. Some of the more interesting stuff happening in that kind of cloud-native space is the idea to try and create some standards around these cloud-native primitives. Probably the most sort of successful one of those has been the Open Tracing API. And this at least is a good sign from the CNCF. They haven't fallen into the pitfalls that we saw, for example, during the web services movement, where a lot of these standards were designed and defined up front. Instead, they're waiting for real-world use and extracting these standards from popular products that work well. The Open Tracing API is now widely supported and allows you to look at how you handle tracing through our systems in a really effective manner. And a lot of these efforts are being driven by a lot of big vendors now. And this is probably good as well, because hopefully we'll start seeing more cloud providers providing these higher order abstractions that may well be more compatible. Again, the data layers, when you get into the fast platforms between Azure and Microsoft, so Azure and, say, Amazon, they're sort of equivalent-ish. There's a whole lot of caveats around that. You know, the very poor language support, for example, on Google, so you've got limitations. But when you get into the data layers, the differences between those vendors is quite vast, actually. There's a lot of difference between how you make and manage DynamoDB versus whatever one of the 27 Google databases you pick, or Cosmos, because the compatibility there isn't the same, and that might be nice to see if we start to see a bit more compatibility. The closest thing we've got is targeting a relational database, right? Because that's probably more portable, but it's not really that's too low level for us. I come back through this whole journey thinking, well, okay, this is about just new abstractions. This is about pushing the work out to other people that have implemented those abstractions better than I can implement it. I was thinking over this thing the other night, this sort of 4 pillars of cloud native from Pivotal. Note that Pivotal correctly dropped the hyphen in microservices, which I think is a big reason why their IPO was so successful. But the 4 pillars, and I realized, well, actually, when you think about all the things that we are bringing together under the banner of cloud-native applications, it's even more nuanced than that. I'm quite fortunate. I'm now in my 20th year as a professional-ish programmer. And during that time, we've seen a huge explosion in new movements and technology, things that I think are all reinforcing each other and are helping us get better. We started off sort of agile and lean. And from that, we sort of had DevOps and the continuous delivery movements come out of those. Continuous delivery and DevOps obviously influenced each other an awful lot, even though they started off as being sort of quite separate in some ways. Out of that, we also sort of learned and understood the cloud. Not only was the cloud made possible by these ideas, but though the cloud itself made those ideas much more viable themselves. It's much easier to do continuous delivery if you have a cloud platform. Microservices are not a new idea. I spend most of my time when I talk about microservices talking about Parnas and from 1971, right? But these technologies, these platforms, these ways of working made microservices a much more viable idea. And now we've got cloud native, building again on all the ideas that came before. This is it. You're just buying into a new abstraction that is hopefully built on some smart ideas and some smart technology. Last thing I'm going to leave you with is this question I get. Is it for me? Should I be building a cloud native application? Is that the kind of thing I should be doing? I hope you ask why and should I before you start. That always worries me. The question I often ask my attendees when I do workshops is, so why do you want to use microservices? And the worst answer I can possibly get, and I get it more than you'd think, is I don't know, my boss told me to come here. That's a bad reason to do anything unless it's avoid getting fired. But that's not a great reason to make some new massive technical change, right? You do need to ask a question, should I be building a cloud-native application? Well, here's some things. These are some things you're going to need to do if you want all these lovely benefits, right? You're going to have to buy into a platform. You're going to have to pick a platform and say, yes, this is the platform for us, and we're going to accept that this is the platform we are going to use. We're going to have to accept the ground rules that comes with that platform, and that's part of it, right? Part of it is accepting that. You're also probably going to need to be a bit smarter about continually looking at the new technology that's coming out, because guess what? The abstraction levels keep rising year on year on year, and that's a gravy train that you want to be on. You're going to probably need new skills. Even if you're already on the cloud, you probably need to be deeper into that. You're probably going to have to grow deeper skill sets around the cloud platforms you're working with. and accepting the constraints. If you do all these things, right, you're going to be able to potentially massively reduce your operating costs. A lot of that next step that you get in reducing your operating costs is about accepting those higher order abstractions. If I'm adopting a fast platform, the platform itself scales up, scales down. I'm not trying to tune my auto-tuning rules and monitor. A lot of that's just done for me. That massively can reduce. It does not eliminate. It doesn't eliminate the costs, but it does reduce them significantly. That in turn is going to let you move faster. You can get things done more quickly. And you're also probably going to be able to deliver a much higher quality of service to your customers than you would otherwise be able to do. Because the application will be more secure, it will be more reliable, because you're working with experts that can do that and can optimize for that at scale in a way that you probably can't. Thank you so much for your time. This was just a whistle-stop tour of my angst and internal loathing at being old. Books are sell over there. I don't talk about cloud native in the book. If you didn't like this talk, that's fine. But we do now have, I think, 5 minutes for questions. If anyone has any questions, and my glamorous assistant, can you wave, glamorous assistant? There's my glamorous assistant has questions if anyone wants to ask any questions.
Thank you, Sam. All right, let's pull up Slido. OK, questions are coming in still. So do we need a multi-cloud disaster recovery strategy for cloud-native applications?
Depends what you mean by multi-cloud. I think if you mean multi-cloud, you mean multi-vendor? No, it's a terrible idea. If you're just doing multi-vendor for DR implies a quick turnaround, either a warm failover or a hot failover or some sort of variation of that. There's all kinds of issues around multi-vendors that are going to cause issues. You're talking about latency across cloud providers, complexity of you working with an abstraction, and almost always you're looking at sort of how these things fail. You're actually often better off just running maybe in multiple regions or the equivalent for that same cloud provider. A good example of that would be, say, your application is based in North America, you're running in the US East Coast. You might also decide to have your application running out of the US West Coast and have some failover. But probably if you're doing that, you're going to be wanting to stay in the same vendor for a given solution. Now, I think you've got to fold into that, looking at how those application platforms fail, the requirements of your app, the engineering required to go cross-region with a solution is quite expensive. Netflix, for a long time, didn't have a cross-region need. They ran out of multiple regions, but they didn't do region failover for quite a while. It took them a long time until that was a cost-effective move for them. So you've got to look at your own apps, but not cross-vendor. There are other reasons to be cross-vendor, but if you're going to be cross-vendor, that might be an organizational decision, but probably any given solution will be in one vendor because of all the latency and cost issues associated with that.
Thank you. What do you think? What will be the next abstraction after serverless? Put on the thinking cap.
Yeah, I think we're still early days of understanding how useful this abstraction is. I mean, I think we like writing little functions. Some of the interesting challenges, though, is that interconnected relationship between code that Adam was talking about in the previous talk. That is there, but it's much too implicit in how we deploy our functions. That makes it very hard to understand the implications of what we're doing. I wonder if we'll start seeing maybe some sort of higher level view of our code that's a bit more topological, where we can be defining the logical relationships between these things in a sort of a different way. There's some optimizations you can do in the cloud platforms. It's still really good because it's a lot closer to the code. I would actually say there is a good 2 to 3 years worth of work from the main cloud vendors of just making their fast implementations suck-less. If you've ever tried using Lambda on AWS directly, that experience is really terrible. That's why everyone ends up using frameworks on top of this stuff. I also think the data stuff is still really quite confusing. That if you look at under the serverless banner, there are so many different databases that talk about being serverless, but a lot of them actually aren't. You know, you're sort of having to manage around concrete limits on things like Dynamo and Cosmos. So I also think we'll start seeing more true serverless, hands-off data storage layers and improved levels of abstraction there.
Cool. All right. For what is cloud native, watch the talk again. It was recorded, I think. And the next question is, how do you get your day job done managing a product and staying technically relevant too, keeping up with the avalanche of tech changes?
Well, it depends on what you mean by being a product owner. But I would say if you're a technology company and you are managing a product as part of a technology company, part of your job is staying relevant to the tech changes. Right, that's just part of the job. So then you're going to need to sort of find some filtering mechanism, right? So you're going to have to find trusted sources where you can get information, come to awesome workshops and conferences and learn from these things. But this is not separate to your job. If you are someone who is a technologist who owns technology, staying up to speed on technology is part of your job. Go read InfoQ, follow nice people on Twitter, find your network. But do this during your do this during your 40 hours a week, right? That's fine. Do it at work, because it is work. We often forget that staying up with new tools and technology doesn't feel like work because it's fun. Just because it's fun doesn't mean you shouldn't get paid for it. So maybe just do it during as part of your day job. Some people I've worked with, they'll take like 2 hours a week to read up on resources. Whatever works for you, but build it into your day job.
All right, so theoretically, we're up with time, but I really want for you to answer this question. What about vendor lock-in? Isn't it dangerous for your business?
So vendor lock-in, very simply, is all about, really when it comes down to it, it's sort of down opportunity cost and option theory in a way, right? When you've got a cloud vendor platform, your concern is, well, look, if I use all these cool things, they'll let me do some cool stuff now. I'll get to go faster, do stuff now. My concern is that later on, the relationship with this vendor might deteriorate such that I need to move. That could be because the quality of service diminishes. It gets shut down, the costs go up. And so then my concern is later on, I might have to move, and when I move, I have to pay a cost to migrate my functionality over. And that's fundamentally the trade-off, is am I worried about paying extra money now by effectively not making use of my cloud platform, or potentially paying extra money later? This is a risk trade-off. It's also not stark, right? Some services, some of the primitives we talked about, are more portable than others. A fast abstraction is fairly portable-ish. It's not too bad. An EC2 abstraction, a compute abstraction, is quite portable. When you start getting into making use of things like Redshift on Amazon, DynamoDB, Cosmos on Azure, and BigQuery on Google, those are much more bespoke services that are going to be harder for you to replicate elsewhere. It's harder for you to replicate the semantics elsewhere. Therefore, you're probably going to have a little bit more concern around the migration cost. So it isn't all or nothing. But I really do think you have to understand it is that trade-off.
Thank you. Let's give a huge applause to Sam.